Good afternoon, and welcome to the Music and Technology Seminar at Carnegie Mellon. Our guest today is Roger Dannenberg, who is internationally known for his research and product development in the field of computer music. Roger is co-creator of Audacity, a digital audio workstation with downloads numbering in the hundreds of millions, and his patents for computer accompaniment were the basis for the smart music system used by hundreds of thousands of music students. Roger is also an accomplished trumpet player, equally at home in classical and jazz, and a composer. For many composers and performers, it's been a fantasy to have a pre-recorded orchestra play back with live performers, with a pre-recorded orchestra tracking the live musicians. Is that no longer a fantasy? Please welcome Roger Dannenberg, who will tell us the answer to that question.
All right, thanks, Ricardo. So, yeah, that's the goal today. I'm going to talk about work I've been doing towards an opera performance using computer accompaniment, and this is going to be a little bit of a thrown together talk with a few slides, a few videos, some mostly demos, I think, and I'm just going to kind of walk you through and talk about the process I've been involved in. So let me share the screen, and we'll start with my title slide, I guess. Here we go. Yeah, okay. So yeah, computer accompaniment goes to the opera. So I've talked about computer accompaniment before, and I think I tried to introduce Accomplice last year, which is the software I've been working on. So I'm going to do just a kind of quick reintroduction to that. And the first thing to do, I think, is talk about, what do I mean by computer accompaniment? So I have this slide is sort of our explanation. A computer accompaniment system is, like Ricardo said, intended to allow a computer to perform music while listening and following live human performers. So it's kind of like the reverse of a click track. In a click track, you record some music and you record clicks for where the beats are, and you get live performers, human musicians, to put on headphones like this, and they listen to the click and they play along with the click. So that's humans following a computer, and that's one way to synchronize, and it's actually pretty widely used now in all sorts of situations. But for many years, I've always thought that's kind of doing it backwards, that we have the capability of computers synthesizing music in real time. And so why would you want humans following computers when humans are naturally vary tempo at least slightly, and that makes the music more alive, and it's also much more fun for humans to follow each other and play expressively than it is to be locked into a click track, which is, not only losing the musicality of expressive tempo variation, but it also is really distracting to human musicians. So if you've ever played with a click track, you find yourself just ignoring all the other musicians and all the interaction and all the collaboration in music, and because you're forced to get the time from this click track, which is completely unmusical, and it's just a distraction. So the way computer accompaniment works is, first of all, you assume that the music is composed. So this is not a system for improvisation, but a system for composition, performing compositions. And so we have a solo score, and which is what the humans are going to play. And just for convenience, I call this solo and accompaniment. That's kind of a little bit more narrow, like, in modern musical terminology. Even when you have a soloist and an accompanist, we tend to refer to that as collaborative performance, and we don't call the study of piano accompaniment that. We call it collaborative performance for good reason. So I just want to acknowledge that. But to simplify things, we're gonna say there's a human soloist and the computer is an accompanist, and the computer has a score as well. This is what the computer is going to play. And so when the live performer plays, we have to get the audio in and do some kind of feature extraction. It might be pitch recognition. If you have a MIDI keyboard, it's really simple. You can just look at the pitches and the note events that come in. But there's some kind of extraction or abstraction, and then you want to form a match between the performance and the solo score, and from that you deduce where the position in the score, and also the sort of the velocity, the tempo that the musician is taking through the score. And you send all that information to some kind of control system whose job it is to try to schedule the accompaniment score events to both synchronize with the human, but also play them musically. So if you find yourself 200 milliseconds behind and you're playing 16th notes, you don't catch up immediately by playing the 16th notes faster than any human could play or any listener could hear. You want to try to make tempo adjustments and position adjustments in a musical way and an acceptable way. And then so that it basically results in scheduling of events like MIDI or whatever control events you have that control some kind of music synthesis and output. So that's the computer accompaniment problem and scenario, I guess. I want to, I thought I would talk about just, one technical thing. This is something I skipped over. Oh, actually what I wanted to do is play a video of Accomplice that I made. And I'm not sure if I played this last time, but it's only a few minutes, so I think it's worth doing this again. Is this going to work? Huh. How about this? Okay, big screen. So this is my description of the software that I'm using now. I want to introduce Accomplice, a polyphonic MIDI input computer accompanist. Accomplice synchronizes accompaniment to a live keyboard performance. Where does the accompaniment come from? You load a standard MIDI file into the program with the keyboard part on one channel and the accompaniment on other channels. Accomplice can listen to you and adjust the tempo and position of the other parts, which you can send to any synthesizer. For more experimental music, you can send O2 or Open Sound Control messages to another program such as SoundCool, PD, Max, or Live. So let's get started with a simple example. I have Bach's Minuet in G already set up so that I can play the right-hand part and Accomplice will play the left. To select the piece, I go to the project window and select from a drop-down list. This is the conductor program, which coordinates with one or more player programs. In the player, we're going to mute the right-hand track so that it only plays the left hand. Back on the conductor, we have some cues set up. Metro means that we'll get a count off, but there are other options. Okay, let's go. Notice that I can speed up or slow down. And Accomplice also ignores mistakes, at least up to a point. To fine-tune performances, the Accomplice MIDI player allows you to make notes more or less legato. You can shift the attack times to get a better groove. You can shift velocities to tweak different voices. And even map channels or tracks to different instruments without going back to a MIDI sequencer or music notation editor. I think you get the idea. Imagine playing with a whole MIDI orchestra. We can do a lot more than play conventional MIDI instruments. This is a little patch I created with SoundCool to play some sound files. For example, here's the first one. And here's the fourth one. These can also be triggered using Open Sound Control, and here you see the port number is 8001. So for Accomplice, I wrote a little piano piece in Finale, saved the MIDI file, and I created a second file in Allegro, which is a text-based music notation. Here's the score, which says, first of all, that the tempo is 131.953, which is actually the precise tempo that Finale put into the piano score MIDI file. And this piece is in 4/4 time. On track 2, I have some OSC messages. The first one says, at the time of 4 whole notes, which is measure 5, send the OSC message to address /4/push1 with an integer parameter of 1. This should be displayed graphically as a note with pitch C6 and quarter note duration with the string SND1 next to it. All the other messages follow the same format, so this score is going to cue some sounds in time with my performance. Back at the conductor, I can select this project. Accomplice loads the configuration information and scores from a directory, and we're ready to play, so let's hear it. Listen for the electronic sounds that come in automatically. This is only scratching the surface of what Accomplice can do. You can set up cues so that Accomplice will take the lead and set the tempo. You can control audio processors such as delays and pitch shifters to modify the live keyboard performance. You can connect to an acoustic piano that has MIDI output, and you can even synchronize video playback. Accomplice is open source, free, and running on Mac OS. It will also be released for Windows and Linux, and I hope you can use it to create some interesting music. Please let me know. Okay, so yeah, so that shows you kind of some of the capabilities. And one thing I thought I would describe, I didn't talk about this before, but this is kind of at the core of the problem is the problem of sequence matching. And you know, I think that's especially interesting now because so many people assume that you know, all hard problems can be solved with deep networks and deep learning, and that's the right approach. And I think in this case, that's not true. It's still the case that the work that I did like 40 years ago is still probably the best approach to this problem. And that's what we've implemented and we're doing. And just to illustrate what the problem is, oh, let's see. I really wanted to, let's see, show this. Yeah, okay, so just to check, you guys are seeing a slide that says sequence matching?
Yeah, we're seeing that.
Someone? Okay, good. Okay. So, so imagine the score is the sequence, and these could be pitches, probably. Let's think of them as pitches. So you have the sequence A, B, C, A, D, E, D, A, and the performance is A, B, A, D, F, E, D. So there's some mistakes in the performance, or maybe in the sensing. Somehow, they're not going to be a perfect match. And so the accompanist has to deal with mistakes and problems that come up. And, you might look at this and say, well, you're making the problem really hard because you're only looking at pitches. So when musicians are synchronizing, they're following the beat and they're using timing, and you can just sort of tell from timing, just count measures. You don't really have to do anything else. You don't have to know what their part actually says. And that's pretty much, to a large extent, that's true for humans and musicians. But if you try to get a computer to pay attention to timing, well, first of all, if the timing were really reliable, then you wouldn't need score following or matching. You could just play at a fixed tempo and everything would be great. But, it's sort of the premise of computer accompaniment is you have to adjust to timing variation. And if you look at timing variation in actual human chamber music performances, for example, you find very wide fluctuations in tempo. At least locally, you'll see, speed changes of 50% or, twice as fast for a moment. And so if you try to rely on timing as part of the matching, there are cases where it probably helps, but there are also many cases where you're going to fail. And so pitch sequences seem to be a pretty robust way to go. And so when you have a pitch sequence, let's see, the problem is you want to find sort of the greatest number of matches. That might not be the most musical thing to do, but you have to formalize this problem as a computer, an objective programming problem. And this is a pretty good heuristic. Just match as many pitches as possible. So if you think, all right, so this is the maximum number of pitches we can match. So the sequence of matches A, B, A, D, E, D is called the longest.
Without Torre, but just because he has this gorgeous view at the top of the tower overlooking the
I think
Rhine.
somebody
Only
needs to
workers
mute,
can go or their
please.
friends, but he's invited me.
So this is called the longest common subsequence of these two strings. And you can notice that to achieve the longest common substring, it's equivalent to removing some elements from the score and removing an element from the performance. And so one way to look at the problem here is if you say every time I remove something that doesn't match, I'll assume that costs something. And so we have this total cost here, which might be 3 if you charge 1 point for each deletion. In different formulations of this problem, you can charge higher cost for notes that are in the performance that are skipped, and or lower cost. So I'm not going to go into all those details, but now the problem is, so how can you actually compute this longest common subsequence? A really standard go-to approach in computer science is what we call the greedy algorithm, or greedy algorithms. The greedy approach basically says that at each decision point, you make the decision that gives you the most good or costs the least. So that's called, that's being greedy. And oftentimes, if you're lucky, greedy algorithms work really well. So we can apply the greedy algorithm to a sequence. So here's a score that says A, B, C, D, E, F, and let's say the performer performs A, and so the greedy thing to do is say, well, let's match this A with this A. So that sounds good. And then there's a B and we match up the B. That's the greedy way to go. Then we find a D. And so the greedy thing to do with D is, well, if we just skip the C, we can match the D, and we want to match as much as possible. So let's be greedy and grab that D. But now what happens is the performer plays a C, and we can't go backwards once we've skipped something, at least the longest common subsequence formalism says you don't get to reorder things. If you could reorder, then, all kinds of crazy things would happen. Musicians don't play scores backwards by mistake. So we don't get to match the C. Then there's a D, and the D has already been matched, so we can't match that. But here's an E, so greedy says, okay, we'll match the E with the E. And so we end up with 4 matches. We've skipped C, F, C, and D. So we've skipped 4. But notice that if we would have, instead of being greedy, if we had held off on the D and waited, we could have matched C and D and E, and eventually probably taken care of this F. Well, we could take care of the F either way. So, but by matching C, D, E and skipping this D, then we have a lower cost. So the greedy failed to find the optimal solution. And you may think, well, this is a special case. Greedy is good enough. It turns out it's really not good enough. It can make some really bad mistakes in the worst case. And so, is there a way to do better than greedy in keeping in mind that we have to make these decisions online and in real time? So the full algorithm is probably too much to go into here. I studied similar algorithms as an undergrad and did work problems, and I'm sure I made an A in the class, but even then I didn't really understand it until later. So it's a little much to go through here, but just to give an idea, suppose instead of doing greedy, suppose we can compute the lowest cost or the best match between what has been performed so far. So, pick some substring, like you've performed up to A, B, D, and you want to consider matching A, B, D to each sequence of notes in the score. So we match A, B, D to A, match it to A, B, match it to A, B, C, A, B, C, D, A, B, C, D, E, and so on. So we have, let's say, up to N different possible strings that we match A, B, D to. And then when we get a new performed note C, we consider, so we know how well so far that we've matched up to A and up to B and up to C and up to D. And so for each one of those problems, we consider, what if we extend our previous solution with a new input, C? So that takes N computations, but these computations can be done quickly because we've saved the cost numbers for each of the possible candidates. And so it turns out that this can pretty quickly not only compute the greedy answer, but compute all other answers. There's actually an exponential number of ways to form common subsequences. And by sort of cleverly caching these intermediate results, you can compute the optimal cost over an exponential number of different ways of matching. So it's an extremely powerful algorithm. This is part of a class of algorithms called dynamic programming, and that's what we use. It's also a little more complicated in that we're matching chords instead of individual notes, but kind of all this has been extended to deal with chords and with long scores where you don't actually look at everything. And so that's where the complexity comes in. Okay, so now what I want to do is switch, oh, yeah, so let me talk about the opera. We're going to go back to QuickTime and I'll show some video. Let's see. Yeah, okay, I'm going to start. The section that I've been working on that I have to show you is from part 2 of this 3-part chamber opera. It deals with some pretty heavy subjects of bullying and abuse. The second section is I guess sort of a mature rated. The scene is a prostitute who has to give her money to her pimp who's demanding money, and she needs the money to pay her rent. So it's, you know, it's a very sort of terrible, abusive situation. The chamber opera as a whole is not all that dark, but this is a pretty dark section. So anyway, I'm going to play a performance that we did without accompaniment. This is, and this was a version that we created for, and I say we, this is co-composed with Jorge Sastre, a collaborator in Spain, and we worked with a vibraphonist, and we created this score for vibraphone and electronics. Sorry about the, let me see if I can kill the phone here. Okay. Sorry about that. Yeah, so let's play a little of this. You'll see the vibraphonist on stage with everyone.
Por favor.
Okay, we'll I think I'll stop it there. So I forgot to warn you, this is in Spanish, but it's, as I said, he's saying, where is my money? And she's basically saying, you know, por favor, please, please. She needs the money. Um, uh, so there were some electronics in that. We did that with fixed little sequences of sound that were cued in time. It creates all kinds of problems with the. We did not use a click track because we had to be flexible with the singers, and we didn't want to, you know, strap headphones and click tracks on the singers. So we would carefully, you know, at the right moment, we could cue some sounds and hope that the vibraphonists and the singers could hear them and get the tempo from the sound as much as they needed. There were places where we just, you know, had to cut accompaniments and leave it to the vibraphones because it was just too hard to coordinate. There were places where we altered the score to make like give a stronger sense of beat so that people could hear it. So we, you know, we tried all kinds of things to make this work. So the new project that we have is to perform this with piano rather than percussion, and we'll use the piano output to drive score following and computer accompaniment and make everything much easier to synchronize, I hope. So I want to show you sort of how, let's see, this leads to, yeah, here we go. The score and all the sounds for with the vibraphone version was done in Logic, and I'll play. So what I've been doing is going back to the original tracks that we had for the vibraphone. We stripped out the vibraphone part and put in a piano part, which is just a kind of rearrangement with some new things added, but I'm sticking to the basic original orchestration. And just to give you an idea what that sounds like, here's the same, you know, well, the introduction. I'll start just a measure before the piano comes in. I'll play a little of that. Oh, and I forgot to add, so there is some, you know, this is supposed to be a street scene, and so there's some kind of sound effects. You hear the siren in the background. That's actually this audio file in blue right here, which of course can't be synchronized. Well, we're not doing any time stretching or, you know, variable timing on the audio tracks, but not really necessary. So here we go. So that the voice sounds that you hear are actually this top track, and that comes from Finale. It's not great voice synthesis, and it's not something we're using in the opera, but it's just kind of a reference for development and mixing and balancing. And so as you can see, there's a bunch of tracks. There's like 11 or 12 MIDI tracks with synthesizers. And so what we're doing for, well, in this, so here's all that. And then, so this was originally developed in Finale, and then as notation, and then imported into Logic as MIDI files. So and then worked on further with Logic. So for selecting sounds and sometimes splitting the same, duplicating the same voices from Finale into multiple tracks and giving them to different instruments and so on. So a lot of work in Logic, just sort of to get the right sounds. And that also includes, let's see if I can pull up the mixer. Yeah, so each one of these tracks, if you've worked with Logic or something similar, you know that each one of these synthesizer instruments can be routed to a separate track, and each track has its own EQ and sometimes delay and other effects, and everything can be routed to reverb, multiple reverbs. And so there's just a lot of sculpting and playing around with the sounds to try to get a good mix. So once all of that was done, that was, fortunately, we decided to use Logic for the performance. So what we can do now is keep, all of the mix and keep all of these instruments exactly the way they are. But rather than playing them from a sequence, which is not going to, it's going to play back at whatever tempo you tell it, but you edit it in there. We're going to play MIDI from Accomplice into all of these tracks. So we'll get the same basic sounds, we'll get the same EQ and the same mix, but the timing can be synchronized live. So what I want to do now is start up, let's pull up some MIDI players. So what I'm going to try to do is kind of simulate the performance and show you what the development looks like. I have all of the MIDI saved in this MIDI file, and I loaded that into, we'll call this the left MIDI player, which is part of Accomplice. And so this is just a MIDI player. I can click play, and it starts. No, this is actually playing. Actually, let me just double check. Yeah, this is sending output to IAC bus 1, which is a software device, and that's being routed over to Simple Synth over here, which is just, so this is my virtual piano player, because I can't play this. I can't play this live to test it, so I'm using a MIDI player to play the piano part, and we're synthesizing it here. And then later, in just a minute, I'm going to start up the conductor, and we'll feed this virtual piano into the conductor and let the conductor follow it, and then we'll be able to screw around with the tempo to speed it up and slow it down and see what happens. So that's the testing part. To run the accompaniment, the accompaniment has its own player with the entire score in here. So just to make a quick check to see if that works, I'm going to type in a starting point, bar 20, and let's play. Okay, so I have a problem here, which is that is also going to IAC1, which is wrong. I want that to go into Logic Pro. And this isn't, to us, it's an output. For Logic Pro, it's an input, but let's try playing again. Yeah. Okay, so that's what you can see. The mixer levels are running, and so we're running 12 different tracks from this MIDI file into Logic Pro. So the next thing I want to do is I'm gonna mute the piano part over here because I don't want to hear the piano. And over here, I'm going to solo the piano part on the left player because I don't want to play the pianist is only going to play the piano part. And now we're ready to fire up the conductor. So here's the conductor part, and I need to tell this MIDI player, I'm going to hand over control to the conductor. And for reason I need to fix, it unmuted the piano track. So let's mute it again. And, I guess while I'm at it, I better check that we're still going to Logic Pro. Yeah, we are. Okay, so now what I'm going to do is I'm going to play the simulated piano player, which is connected to the conductor. Oh, let's check. The conductor input is coming from IAC bus 1. So the piano player is playing into the conductor. The conductor is controlling the right-hand piano player, and the right-hand piano player is sending MIDI out to Logic Pro, and that's what you're hearing mostly. Okay, so I'm going to start playing the MIDI player on the left. It's going to take it a few seconds before it hits the first note, and so while it's running, I'm going to run over and click start on the conductor, and let's see, they're both starting at measure 7, which is still a rest. Okay, and so after the piano plays for a while, we should hear the accompaniment come in. So play, start. Okay, so I can pause the piano and restart it, and hopefully things will sync up again. You can see on the right maybe that it's practically stopped playing. And another thing I can do is I can play with the tempo just for tests. So I'm going to make it play really fast, and we'll see what happens. Okay, so anyway, that gives you an idea, hopefully. So one thing I'm not doing, cannot easily do here is simulate mistakes that the pianist makes, or for that matter, realistic, anticipating actual pauses and synchronizing with the singers and variations. I can certainly speed it up and slow it down, but what's going to happen in real life? We need real life rehearsals to find that out. So I think, yeah, the other thing I wanted to point out, and then I'll be done, is we sort of anticipated that at rehearsal, the balance might not feel right, and so we have, as you saw in the video, we have a lot of options. Like we can go to, well, first of all, we can mute or solo any track. We can change the velocity in real time, or in not just making adjustments in rehearsal to bring out one track. We can, oh well, I guess we could do that on the mixer here too, but we can also change some things like the amount of sustain. We can delay notes, so shift them in time. If we think the attack is too slow and some voice is coming in late, we can actually make it come in a little bit earlier. So there's a lot of things you can do live. You can even change the MIDI channel that you send on. Although I don't really want to do that with this, since everything's so carefully worked out with live here. But those are some possibilities. Yeah, so let me stop there, and maybe we have a few minutes for questions, and I can start sharing again, but I'll switch back to video so I can see people.
Yeah. I'm actually currently working with you on a really likewise project about piano duets in accompaniment. Yeah, and there are some questions. Yeah, first, I believe in the MIDI, the velocity and also expression stuff are built in. Is that correct? In the MIDI.
On this, if that's a question, on this system, yeah, all of the MIDI timing and velocity is all built in. So what we're doing in real time is basically adjusting the tempo and the timing, trying to synchronize with the performer.
Is there any possibilities to extend function to track the actual playing velocity or dynamics of the piano player and synchronize it to the MIDI?
Yeah, you could. I think whether that's a good idea depends a lot on the music. So, for example, if the pianist starts playing louder, is that because the music should get louder, or is that because the orchestra is too loud and the piano's trying to balance with it? And so, there's sort of two, in the first case, you want the orchestra to get louder with the piano. In the second case, you want the orchestra to get softer with the piano. And there's no great robust way to figure out what's going on. We don't have any, microphones out in the hall that are listening for balance or anything. I have tried some accompaniment systems where we feed the kind of general amplitude of the soloist into the accompaniment, and that does help get more. That's kind of a form of expression, and it kind of turns the accompaniment or the orchestra into more of an extension of your instrument, because then the player has some dynamic control. In this case, I think, I don't know, I think it would be weird to have like a piano concerto, and every time the pianist, hits a really loud chord, the orchestra, swells up and plays loud. So I think it just depends on the situation.
And
You may also know of my former student, Gus Jha, did a whole PhD thesis on collaborative performance and machine learning, trying to learn better ways of adjusting both timing and velocity in a collaborative way between computer and human. And he did, as opposed to the way that I'm doing tempo adjustment, he was able to sort of spot and actually anticipate expressive changes. Like if a piano is moving up to a point where they're going to slow down or insert a little bit of a pause, you can actually predict that from the notes that are happening beforehand, which is pretty amazing. So and by doing that, my system just kind of extrapolates the current tempo and says, well, you're going to play at the current tempo until you indicate otherwise. So it can't really anticipate tempo changes that are happening. And Gus showed that by anticipating those tempo changes, you can greatly improve the synchronization, but only in cases where things are extremely expressive, and also only when you can have 4 to 8 good rehearsals and really do some training and work. So if you're going for a public performance on stage and you want something to be as robust as possible, it would make me nervous to try to go out there with very limited training data and possibly have the system try to respond to something that it's never heard before. So those are some trade-offs that you have.
I had a question. I'm just wondering, so from what I understood, unless there's more going on that you didn't get the opportunity to talk about, so the bulk of the processing is just listening to the notes and figuring out where in the score they are, given the possibility of mistakes and tempo variation, and aligning the MIDI accompaniment to speed up and slow down to match where you think they are in the score. Is that?
Yeah, that's most of it. It's not simply speeding up and slowing down, but it's also like it has the capability of jumping ahead or stopping or even skipping notes in extreme cases. So it has some it's basically using a rule-based system to try to choose a musical thing to do, to correct for unsynchronized, when you detect things are not synchronized and you should be at another position at another tempo. The question is, okay, what are you going to do about it? And it's not simply a matter of speeding up or slowing down, but it could involve jumping and skipping notes as well.
Right. So essentially, you're trying to make it a little more musically adept.
Right,
to
right.
respond to what it's listening to.
Right.
How do you solve the time difference between, how fast is this algorithm or whatever instructions you're giving it?
Oh yeah, that's a good question. It's we're running about, I actually forgot, but it's 50 to 100 milliseconds ahead of like it's projecting ahead 50 to 100 milliseconds because there is communication between the conductor and the player, and there's some latency in the whole system, and MIDI output has some latency. And it's that latency that allows me to go in and say, hey, I would like this track. It seems to be lagging a little bit. I want to start playing those notes 50 milliseconds early, and you can actually, it seems like it's violating causality or something, but you can do that because you've anticipated when to play. So there's that. The actual processing time is down in the millisecond or 2 millisecond range, but we're anticipating. But then if you're behind and you need to catch up, like I said, you don't want to just you don't necessarily want to skip notes, and you don't want to play all the notes at 1,000 beats per minute to catch up within 50 milliseconds or something. So what we, part of the solution is we can say, well, if we're only a little bit behind, we're going to speed up a little bit, and we're going to anticipate that a couple of beats from now, we will catch up. And so we're actually making a plan 2 beats in the future that we're going to, that's when we're going to catch up. So that way we don't have to make the accompaniment go real fast. And I think that's comparable. I mean, that does happen with orchestras and soloists, that, one will get a little ahead or one will get a little behind. There's like some flow there. And if you realize you're a little behind and you speed up in order to catch up in a couple of beats, it can be very musical. So that's what we do. And actually that lag time is, one thing I didn't show you. Maybe I can do this real quick. Go back to sharing. On the conductor, we have a thing in the menu called convergence, and that's how long it takes. If you're going to speed up and slow down to reconverge, how far in the future do you want it to be? So if you're going at a very steady tempo, you can set the convergence, way out in the future. So if you're 20 milliseconds behind, then you just barely speed up at all, and because you don't really know if you're behind or the pianist is ahead. And you don't know what the pianist is going to do. So anyway, you have a range of convergence factors. And then another thing we can do in the conductor, which I forgot to show, is we have cues. So we can say, for example, at measure 45 up to measure 50, I want to set the convergence to 6 beats. So we're going to assume this is very steady tempo, and we want, maybe the pianist is essentially going to follow the accompanist, and so we don't want the accompanist to react to the pianist. Maybe it's playing a drum beat or something, and you want it to be very steady. And in fact, the extreme case is we can put in either a tempo cue, which says we're going to stop following for 5 measures from 45 to 50, and we'll just play whatever tempo is written in the score. And there's also another variation of that, which is hold, which says at whatever tempo the accompanist is playing, that we think the accompanist is playing at measure 45, we're going to lock that tempo in, and we're going to hold it and play steady for 5 measures. Because again, this would happen if suddenly the accompaniment was a very steady beat played by percussion, and they have no business following the soloist. The soloist should be in lockstep with the percussion beat. And then when you get to the end of that, you can put in a new cue and make a new strategy. So there are ways of kind of feeding extra information into the performance to get, to sort of customize it.
I have a question. With all this, all I can think about is, hooking it up to like a Yamaha Clavinova, a beautiful instrument with MIDI embedded into it. And so I'm wondering, are you able to take that, like, let's say, not time stretch data, but that time manipulation information and apply it to a waveform audio track so that you can have maybe a more responsive, more realistic orchestra?
Well, I think that there are two questions there. So in terms of so ideally, I would love to do this with an acoustic piano, like a disc clavier, a Yamaha disc clavier, or a Bosendorfer with MIDI output. That would sort of be the best of both worlds, because you would get MIDI, easy, or easy to follow MIDI data from the piano, but you get the acoustic sound in concert of a real acoustic piano. We're going for the opera. We're going to be using a electronic piano MIDI keyboard, because we're just not going to have access to an acoustic piano. And then but you mentioned more realistic sounding orchestra, and so the sound of the orchestra is sort of independent of what the piano sounds like. So this opera is intentionally a little bit electronic sounding, and there's also some real-time effects, like granular synthesis and other things that we're applying to the singers and the piano, which I didn't get into, but we're doing that too. But yeah, if you want a more acoustic sound, well, first of all, you could possibly work really hard and get a more orchestral sound with MIDI. Another possibility is, at one point we had, well, at least a prototype for a player that, instead of playing MIDI, it plays audio and uses real-time time stretching. In fact, yeah, wait, let me see if I can quickly pull up something. Ricardo helped with a lot with yeah, let me play a bit of this recording. This is, I forgot what year this was. This is a while back, but yeah, I think we're sharing again. Yeah. Okay, so this is the CMU Jazz Ensemble. We're doing something like accompaniment, except instead of matching, we're foot tapping. So I won't go into that, but the point is that we have a 20-piece string orchestra that is being played by these 8 studio monitors in the back, and the sound quality was just amazing. And these are real string players recorded into 20 tracks and then time stretched in real time to adapt to the orchestra. So I'm going to just jump to someplace. Maybe hopefully you can hear the strings. So that's Dave Pello on live upright bass playing the jazz solo, but that's not the string I'm talking about. Okay, I think there you can hear the rising line in the strings pretty clearly. I'll play a little more of that. Let me go to it's a little bit subtle, and there's so much going on. Let's. So you could hear, hopefully, it's just a really seamless integration between the string players, which were all virtual, and the live jazz performance. And you know, this recording doesn't do it justice, because with the 8 monitors across the stage, we got this real 3-dimensional kind of sound field, and we were using the natural reverberation of Carnegie Music Hall. So it just, you know, sounded great. It sounded so great. Maybe the only problem was the strings were, like, you know, studio recorded and edited. So in live performance, in some ways they sounded much better than the live players. It just, not that they sounded not. I mean, better is a funny word. Like, I don't really mean they sounded better, but it was a little bit striking that you heard this kind of like perfectly pitched and everything perfectly together string sound, and then, you know, a little more, you know, live, rough and ready jazz ensemble. So but anyway, that's, you know, that's a possibility. But then to do that, we relied on live performers to, you know, very painstakingly record a big audio recording. And so, you know, we can, if we have the sound of an orchestra, we can adapt it to live performance, but we've got to get that sound somewhere.
Roger, I remember that project very well. I remember recording all of the people here in the strings in the studio in August recording studio.
Right.
I don't mind what you're doing until the very moment that you showed that video.
And I want to tell a story on Ricardo, just because I'm so proud of you know, the result we got. That when we were doing the sound check in the hall, and I put the strings up across all these speakers, and we listened to it, Ricardo said, "Wow, that sounds really good. What kind of reverb did you use?" And there was no reverb. It was completely dry. But it was, you know, it just interacted and fit into the room because you know, each speaker was playing 3 or 4 string players, and we had the violins on the left, the cellos on the right, and you know, each one was putting out a dry signal, just like you know, real string players. They put out dry signals, but you spread them across the stage in a concert hall, and then suddenly it sounds just, it's natural, that, you know, by definition.
Yeah, that was Carnegie Hall in Munn Hall Library.
Right.
So Roger, I have a question.
Sure.
Someone who's been seeing these talks for what, 35 plus years now. I'm curious what you think is the most, you know, I mean, what is the most the most significant thing that you think that has changed between what you were doing 35, 40 years ago and what you're doing now?
Yeah. Well, for one thing, we have a lot more tools for like developing scores and refining these MIDI sounds, like with Logic running, you know, 13 audio channels with independent EQ and synthesis control. And so, you know, I think the technology has certainly changed a lot.
Getting MIDI to work in real time back then was a chore. So.
Yeah. So, but otherwise, you know, like we did with an early version of polyphonic accompaniment, working with Mark Burnell, who is now living and working in Chicago. Mark performed Rhapsody in Blue, and he also entered the entire orchestral score for Rhapsody in Blue as this huge MIDI file that we synthesized on a Yamaha DX, TX-802. Was that the 8-channel DX7?
Right.
So he got all the stuff to work and performed it, and it sounded like a Yamaha DX7 playing Rhapsody in Blue, but it got through it, and it accompanied him, and that was all running on a Mac Plus computer. So in some ways things never change, but we never did that in a live concert, and never did anything like an opera. So this is something we could have done back then, I suppose, but as far as I know, it's never been done.
Roger, where and when is the opera?
Oh yeah, so unfortunately for people here, the performance will be in Spain. I don't have a date yet, so this is not really definite, but I'm working with a pianist over there and with Jorge. And we also have a second performance of the vibraphone version, which is not using computer accompaniment. This is happening on, I think, February 15th. It's just a little more than 2 weeks away. And so that'll be exciting to do that again.
Where's that going to be?
And that will be, oh, yeah, sorry, and that will also be in Spain and near Valencia. So this is part of a 10-year anniversary celebration of Sound Cool, which is a project I've been working on with Jorge. I've talked here about Sound Cool, and you saw a little bit of Sound Cool in the demo video that I played. It's a tool for teaching electronic music and rapidly building interactive electronic systems for all sorts of things.
And any plans for doing one in Pittsburgh?
Well, I would, this, as you know, we did, my first opera with Jorge was The Mother of Fishes, with a almost 30-piece orchestra and 6 singers, and it was a huge undertaking. And after years, I managed to produce that in Pittsburgh. This would be much easier to do. By when we get the piano thing going, it'll be performable with one pianist and a couple of singers, but still requires some staging and rehearsal time and a lot of work. So I would love to have someone do it in Pittsburgh. I'm wondering even if there's some class or workshop or grad students in the School of Music might be interested in doing it, which would be fantastic.
Are there any other questions? Okay, I think we can stop recording. And I just have one quick remark after you stop recording.